Okay, so today we're going to be looking at concave mirrors, or what is another name for this type of mirror is called a converging mirror. So two names, which is always nice to have to memorize. You can tell a concave mirror because it caves in away from you. So it's like looking in the mouth of a cave, I think of. It goes inward. So some vocabulary you're going to need to know. Your concave surface, reflective surface, caves in away from you. So you can see it here is the reflective surface. The principal axis, it goes right through the center of the concave mirror. And then you have some other terms. One is called the focus, which we're going to be using when we're doing our ray diagram. So it's a point you're going to be reflecting light through. And the center of curvature, if you think about using your compass and to draw a circle, you would put the point of it right here. And then that would be the center of curvature. So you would draw obviously I'm not great at that, but that would be the center where you would draw that circle that goes around. So just some terminology that you're going to need to know. Oh, it's not even letting me erase it. That's nice. There we go. Okay. So now I have no idea what goes on with this program. So you're going to have to bear with me here, because when you print out your sheet, you're going to have these lovely diagrams here. And I have a mess of rays. That's all I have. So I will draw in, just roughly sketch what these are supposed to look like. So your incident ray is showing the light ray shining in. So the first one is saying if you have, here's your principal, we'll make that the principal axis. So I'm going to draw my own, I guess I should make that higher. Okay, I'll make it a bit higher here. So anyway, bear with me. Principal axis, there is the concave mirror. Okay, so when you have, and then the focus, center of curvature. So when you have an incident ray coming in parallel to this principal axis, this line that goes directly through the center of that curved mirror, when the light, remember, when you draw ray diagrams, you're going to be using a ruler. You're also going to show the direction of your ray. So as long as the ray comes in parallel to the principal axis, it is going to bounce off that curved mirror and go through the focus every single time. Okay? So, and you have a lovely diagram of that. So you don't have a mess of arrows like I do. This one, I'm just going to tell you before we move forward, is what you're going to use often. Okay? So you're going to use the parallel, then focus. And then if we look at the reverse situation, so again, I'll draw the concave mirror. You have this all drawn for you, a focus and a center of curvature. If the initial ray of light comes through the focus, it will bounce, once it hits the mirror, it will bounce straight back parallel to the principal axis. Your diagrams will look way better than that. I can't believe my program keeps doing this. Luckily, the diagrams below are not this, don't look like this. Now, if you go through the center of curvature with a ray of light, it will hit the mirror and bounce straight back. So you're going to use the first one. The second one, I really don't ever recall using. I don't do through the center of curvature and straight back again, hardly at all. I like the first two, but sometimes the first two aren't good enough or they just don't work. So for my third one, I tend to use this one. So if you have a ray of, oh boy, that's not, it's a little shaky. If you have a ray of light, you can actually take that ray of light and have it hit the vertex. Oh, I didn't mean to do that. Wow. This is good times. I cannot wait to get back to class in September. Okay, here we go. Let's try this again. So if you have a incident ray, the ray of light coming in, and it hits right at this vertex, okay? That is this point right where the principal axis hits the center of the curved mirror, okay? So if you have a ray of light that hits at the vertex, it acts like a plane mirror at that point. Acts like a plane mirror. And in doing so, angle of incidence, so you can measure that angle, and then you measure the angle of reflection. I'll see how I do here. So it's going to come back out at the exact same angle. So the angle of incidence is going to equal the angle of reflection here. So you can use, and I use this one, so these two angles will be exactly the same. And again, your diagram is going to look great because it's already there for you. Mine looks just ridiculous, but that's okay. So there. So the way I do these, and it'll make more sense when I go to the next part. The way I do these is I always try number 1 and number 2. And if I can't do one of those, then I'll use this one to figure out where my intersection point is. And this will make more sense as we move on. So there's the 3 that I utilize most often, and you have lovely pictures of them. Okay. So notes, this is important. So you're going to print this out. So this will be ready for you to go. 2 rays is the minimum you need to find an image. So what we're trying to do is reflect light off the curved mirror to find an image. A 3rd would make a good check. I don't really use the 3rd one. I use the 3rd one if either 1 or 2 doesn't apply. Okay, so when I say 1 and 2, I always say you go about these and you say in your head, parallel, focus, and then you say in your head, focus, parallel. And that will work often, and you'll see what I mean as we move forward. So when you're doing ray diagrams, I tend to do the parallel line through the focus and then another line through the focus running parallel. So I always say in my head, parallel, focus, then focus, parallel, see if I get an intersection, and there's my image, okay? Sometimes not all 4 can be used. So remember, we had 4 different options here. Sometimes not all 4 can be used. So again, I will use 1 and 2, and that will work most of the time. But sometimes one of those can't be used, and then I will default to the 3rd one. You can always do through the center of curvature and back again. It's just, no, not my favorite. Okay, so images that are formed by a concave mirror. There are different options for how that image is going to look depending on where the object that is being reflected is. So, I mean, it was very simple for a plain flat mirror. All you did was take your angle of incidence and reflect it and get your angle of reflection. So if you did your laser light security system, you were doing the same thing over and over and over again. And you're always going to get the virtual image, right? That is upright. That is the same size. That happens. It doesn't matter what you're reflecting. That always happens. In a concave mirror, it really depends. The image you get really depends on where the object is. So concave mirrors, you know, you might think, oh, like funhouse mirrors, right? Sometimes when these mirrors are used in funhouses, you can look really weird, right? It depends how far you are away from the mirror. So different things happen depending on how far the object, is from the mirror. Oh goodness. Okay. So if you're reflecting a real object from very far away, Then the real, so you're going to see the word real here over and over again. That's because for our plain flat mirrors, our image was virtual. These give real images, which means you can put a screen up and you will get an image on that screen in front of the actual mirror. So if we look here, what they've done here is they've taken the top and bottom of a real object from very far away, and they've done parallel focus, and they went through, so this is, they went, okay, parallel through the focus, and then they took the bottom of the very object very far away, and they reflected it parallel focus again, okay? And what they got was a real image that's formed at the focus. Okay, this is not something we're going to be utilizing, but it is an option. Number 2 is a little more common, so let's look here. And number 2 is, this is what I do. This is what I would try for every single one of my array diagrams. You do it over and over again, and it works most of the time. So here's our object, real object, okay? And all they're doing is using an arrow. It just makes things simple. So we're just going to reflect the light from the tip of that object, which is an arrow, and then draw the image. We use arrows because they're just easier to draw. Like we could reflect a person, but then you'd have to draw the person, or the image of the person, right? So an arrow is nice and neat and easy to use. So let's look and see how this works. And again, parallel focus, focus parallel. Just keep thinking that. Parallel, focus, focus, parallel. So let's look. They drew a line from the tip of the object parallel to the axis. So parallel and then through the focus. Don't forget those arrows. You need those arrows showing direction. So the light reflected on this curved mirror through the focus. So there's parallel focus, and then you do this, the second one. Then in your head you go, okay, now I'm going to do focus parallel. 2 lines, right? Not hard. 2 lines, you know, parallel focus, focus parallel, and where they intersect, you draw that dot. And then that, what did you reflect? Well, you reflected the top of the arrow. That's all you reflected. So you got to, that's where the top of the arrow goes. And then you draw the arrow from the axis down, okay? Because you reflected the top, so that's where the top is. And then you say, okay, what did I end up with? Well, when I look at the image is in front of the mirror. First of all, we're not back here like we were when we were doing the plane mirrors. We're in front of the mirror. So our image is in front of the mirror, so we call that a real image. Okay? And then we look at the size of it. We would go through SALT, right? Size. Well, it's smaller than the original here. Okay? So, and it's inverted. It's upside down. Unlike our plane mirrors where everything was right side up, this one is upside down. So the image is inverted, small, and it's a real image. Okay? So that's just some terminology we have to use. It's located in front of the mirror. It's another part, location. It's in front of the mirror. It is inverted, it is smaller, and it is real. Okay? So, and this is just one situation. So if the object that's being reflected is behind the center of curvature, this is a situation that's going to happen. So you kind of want to keep these situations, this page in front of you as you go through, because it will help you and you'll realize you're on the right track when you find your image. So number 3, for a real object at C. So if the object is located right at the center of curvature, what happens? Well, they did the parallel focus, focus parallel again. So watch. They go, okay, I can use parallel focus and then focus parallel. Where do they intersect? They intersect right here. Wow, it's directly under the actual object I reflected. Remember, we just reflected the tip of the arrow there. So that's where the tip should end up, where the lines intersect. We draw that in, and what do we end up with? Well, we still end up with a real image. It's still in front of the mirror. It's inverted, and it's the same size. okay? And that's because the object was right on the center of curvature. Okay, so that's another option that can happen. Again, this one we're not going to really be doing. Okay, number 4. Now we've got an object that's between the center of curvature and the focus. Once again, we can use those two, the first two there, really nice and easy. So parallel, focus, focus, parallel. And where did those lines intersect? Right here. And so we reflected the tip of this arrow, and that's where the tip's going to be. You draw the tip in, draw to the principal axis, and again, you evaluate what you have. Well, we are in front of the mirror. Wow, I didn't mean to do that. Oh my goodness. This happens to me. Oh, there we go. We are in front of the mirror. No, we're not. I'm over here. We're in front of the mirror. And it's real because it's in front of the mirror. It's inverted again, and it's larger. Okay, so again, a real image, inverted, and larger than our original object. Now, if for a real object, if the object is placed right on F, okay, so it's right on the focus. Now we're going to go through what I always said to do. Okay, let's go. We're going to go parallel, focus, but we can't do focus parallel, right? We're on the focus. So this is where we're going to skip right, and we can't do center of curvature because it's behind. We can't bounce, we got to bounce the light off this curved mirror. So that just leaves us with number 3, which is why I always use 1 and 2. And if I can't use one of those, then I go to I believe it was the 4th one on the sheet. That's where the angle of incidence equals the angle of reflection right at the vertex here. So I just act like this point here is like a plane mirror right at that point. So you're going to get this, and you're going to draw the line into the vertex, measure the angle, and reflect it back out so that your angle of incidence equals your angle of reflection. And when you do that, and you will notice when you practice, you're going to have to be very methodical. Your parallel lines have to be parallel to the principal axis, or that you just won't get the right result. Make sure you're reflecting off the reflective surface, which is the front. And you will notice that these two lines extend back parallel, which means they're never going to intersect. They will, so there's no image. There's no image. You're going to see nothing. You might have an object in front of the curved mirror. You're going to see nothing. There's no image for this one. Okay. And for a real object that's now so close to the mirror, it's between the focus and the mirror. Again, you're going to go, okay, how am I going to do this? Well, we start with our basic parallel focus. Yay, that one worked. We can't do focus parallel. We can't go through the center of curvature. We could do angle of incidence equals angle of reflection. That's where we are. Remember, those are my go-tos. So go in, angle of incidence, bounce it back out, angle of reflection. Why don't I have to draw a normal in there? Because the normal is the principal axis. You don't have to draw a normal in there. And for these kinds, when the object is closer than the focus, and again, this is why it's nice to have this little summary with you when you go through and do this, you have to take these reflected rays, which is kind of funky. And I don't know if I would put one of these on a test. But you take the reflected rays and reflect them back. But I guess I could put this one on a test because you have the examples right beside you. It's not like it's an open book test. It's not like a closed book test where you have to memorize each scenario, which is a lot of memory work in this unit. But, hey, it is physics. So you take the reflected rays back, and where those reflected rays intersect is where you're going to put the tip of that arrow, because that's where the image is. And now you're like, hey, I am now behind the mirror. Yes, you are. And so what does that mean? That means you get a virtual image behind the mirror, and the image is upright and larger. And where is it? It's behind the mirror. Okay? So there's 6 options. 6 different types of images you can get with concave mirrors, which makes them pretty complex. So I want you to try to do the rest of these worksheets. Try and do a few ray diagrams. And then we're going to cover convex mirrors. And then I'm just going to give you a little assignment to see how you're doing with your ray diagrams. Some people find them easy, some not so much. Make sure you ask questions if you need help.